guys, it's Mrs. Guess again. Today, what you are going to be working with is when you need to add fractions that have denominators that are not the same. So we call those unlike denominators. We know that the prefix un means not. The word like means the same. So if it's unlike, it's not like each other. Okay? So there are ways to do this. And yesterday we talked about finding common denominators. I hope you remember that. When you're dealing with unlike fractions and you need to add them or subtract them, you're going to have to find common denominators. So one of the ways that they are wanting you to do this, and I'm going to show you this, is you're going to find common denominators. So, and I'm going to show you, they've already got it kind of written out here. I want to show you. If you're lucky enough, you may have access to some of these fraction bars. I've been playing with them in Miss Eichenberger's room. I have to tell you, I love them. But anyway, I don't have any. I need to get some. But anyway, so one of the ways that you can do this, let's say that we are wanting to add, up here in our little word problem, it says that Alex rode his scooter from his house, which is over here, and he rode it to the park. Okay, and then later he rode from the park to baseball practice. Well, from his house to the park is 1/2 mile. And then from the park to the baseball field is 1/3 mile. So what they did was they said, okay, well, we're going to find all of the multiples of 2. And they wrote them down. 2, 4, 6, 8, 10, 12. You guys ought to be able to do it. It's counting by twos. No big deal. And then they found all the multiples of 3. 3, 6, 9, 12. And it could go on and on. Usually you don't have to go too far if the numbers are close together. So they put them in a list like this, and then they started looking. Okay, I have some numbers that are the same, and so they kind of colored them the same. Here's a 6, and here's a 6, and here's a 12, and here's a 12. And they said, okay, which one is the smallest? Well, the 6 is the smallest. So they decided to use 6 as their common denominator. Well, then they did the work to make them the same. Okay, so what they did was they knew that to get 2 to 6, I had to multiply by 3. So 1/2 times 3 over 3 is 3/6, because whatever I do to the bottom, I have to do to the top. And then to get 1/3 to 6, they had to multiply by 2's. And they got 2/6. Now they can work on this. They can do it together. They can add. So now they have 3/6 plus 2/6. Here's the deal. When you are adding or subtracting fractions, your denominator does not change. So if you're dealing with 6's, your denominator is going to be a 6. And then it's really easy. You just add 3 plus 2 and you get 5. So he rode his scooter for 5/6 mile. All right, I'm going to work some on another piece of paper. This one wants us to find 5/12 plus 1/4. All right, so the first thing we have to do, I'm going to move up my page a little bit, make sure I have a clean spot, zoom in just a little bit, but not too much because I don't want it to be blurry at all. So what was it? 5/12 plus 1/4. I'm going to write that right here. 5/12 plus 1/4 equals what? I don't know. Part of the reason I don't know is because I have different denominators. In order to do this problem, they have to be the same. Okay? So the first thing I'm going to do is I'm going to find a common denominator. I can do it 2 different ways. Remember, I told you, you could just multiply the 2 together, and that would be a denominator of 48. That's a big number, and that tells me I'm going to have to do a lot of reducing to get a really good, clean answer. So another thing that you can do, you've got your multiplication chart in front of you. Here we go. This one is 1 through 12, right? So I'm looking at denominator of 12 and of 4. So I'm looking down this row. Let me back it up a little bit. Yes. I'm looking down my 4s and my 12s, and I'm looking for numbers that are similar. So there's not a 4 over here. There's not an 8 over here. There's, oh, wait a minute, look. There's a 12 right there and a 12 right there. Guys, 12 is a common denominator. 4 divides into 12. So we're going to use 12 as our common denominator. So I'm going to rewrite my problem. I do not have to change the 12. So I don't have to do any work with it. What I have to do work with is the 4. Let me tell you what I'm going to do. I'm going to do the work with the 4 and then put my 5/12 down. So I've got 1/4. Now what did I have to multiply 4 by to get 12? And there's 1, 2, 3. So 4 times 3. So it's a multiplying times 3. Remember, whatever I do on bottom, I have to do on top. So 4 times 3 is 12. 3 times 1 is, ooh, that's easy, 3. So I'm going to take my 5/12 from my problem. 5 over 12, making sure there's still plenty of room. And then I know that 3/12 is the same thing as 1/4, and I'm going to add 3/12, right? Okay. Now if I add those together, my denominator is going to stay the same. I'm not changing it. And now I'm going to add the top to it, 8. Isn't that cool? So now I know that 5/12 plus 1/4 is 8/12. That's pretty cool, huh? All right. Let's look at another one. Let me move over here. We're going to do 1/2 plus 2/5. All right. So I know since this is an even and that's an odd, they're not going to, one of them is not going to be a multiple of the other. It's just the way it is. It's just not likely to happen. So now I'm going to look for a common denominator. And probably what I'm going to do, since 2 is pretty low, I'm probably going to end up doing 2 times 5. But let's double check to be sure. There's my column. Here's 2's. I got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Then I got 5's. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Okay, I'll quit doing that. But, all right. If you'll notice 5, the multiples of 5 either end in a 5 or end in a 0. 2 is even. It will not go into anything ending in a 5. So I know I'm going to be looking at just the even numbers. So over here I have a 2. There's no 2 here. Here I have a 4. There's no 4. A 6. Nope. An 8. Nope. A 10. Yes, sir. So we're going to go with 10. 10 is going to be our common denominator. So I'm going to do 1/2. And to get 2 to 10, I must multiply times 5. So 2 times 5 is 10. 1 times 5 is 5. Because again, whatever I do to the bottom, I must do to the top. You're going to get so tired of hearing me say that, but it's true. All right? And then over here, I'm going to do 2/5 times what? Equals 10. Well, 5 times 2. So I got to multiply 2. 5 times 2 is 10. 2 times 2 is 4. Now I can go up here. This is the same thing as saying 5/10 plus 4/10. It's just another way of renaming it. Going to keep my denominator the same, 10, 10, 10. Now, 5 plus 4 is 9. So 1/2 plus 2/5 is 9/10. 1/2 plus 2/5 is 9/10. Let me see if I can find one more problem. I think that's about it for that. Okay, just remember you have to have a common denominator. The most of this work for this lesson was done back on 7-2, the last lesson we did when we learned how to find common denominators. And again, with this one, it was just easier to multiply these times each other. On this other one, we worked on it being one of the same. Let me show you real quickly what it would have turned out with if I had gone and done, it sounds really bad, if I had gone ahead with the idea of multiplying them times each other. So 5/12 times, we're going to multiply times the denominator 4. That means our denominator is 48. 5 times 4 is 20. Then I'm going to do 1/4. Is that still within the... Woo! 1/4, and I'm going to multiply times the denominator 12. So 12 and 12. And my denominator is 48. 1 times 12 is 12. Then I have to add them together. 20 48ths plus 12 48ths. Keep your denominator the same. It's 48. 20 plus 12. 0 plus 2 is 2. 2 plus 1 is 3. Now, there is going to come a time, probably pretty soon, when you're going to have to learn to put this in what is called the smallest form. And that's when we go back in and we look at 48 and 32 and we see what number we can divide both of them by. And in this case, that number is 4. So if I divided both of them by 4 to get back there, that would be 8, and that would be 12. Oops, I can divide again. I can divide by 2 again. 8 divided by 2 is 4, 6, and I can divide by 2 again. I know I'm just making a mess of this. I know I am. 2/3. That's just a little extra. So if you don't want to pay attention to that, that's okay. But that's why I said it would be easier in that case to go with 12, because that's only got one time you have to go down. And I'm not even sure that that one's correct. It's not. But anyway, ignore that last little bit. But just showing you that it can be done both ways, okay? If you have questions,